There are moments when you walk on the warm sand and you can already smell in the air that salty scent that announces the ocean. You move forward slowly. The waves in the distance seem to call to you, and you already know that you will not be able to resist the urge to taste this mysterious water that stretches to the horizon. It looks so gentle from here, but we know that a simple touch on the tongue will reveal all its saline strength. We approach, we dip our hand into this moving expanse, we bring it to our mouth, and then it is an explosion of salt that immediately surprises our taste buds. This taste, so strong, is the very signature of the Atlantic Ocean, and yet it is not the only one to hold this secret. Seawater in its complexity contains on average 35 g of salt per liter. A simple piece of data, but one that hides fascinating nuances, because depending on the seas and oceans, this salinity varies, ranging from 35 g in the North Atlantic to 38 g in the Mediterranean, and much more in certain expanses such as the Dead Sea, which can reach up to 260 g of salt per liter, a true sea of crystal invisible to the naked eye. On the other hand, some waters, like those of the Baltic Sea, contain less than 10 g per liter, giving each sea a unique personality. This salt is mainly sodium chloride. A simple formula that nevertheless tells a whole chemical and geological story. A sodium ion, that is to say an atom of sodium that has lost an electron, joins with a chloride ion, an atom of chlorine that has gained an electron. Together, they form what we call table salt, the one we sprinkle delicately on golden fries, without thinking that it has traveled billions of years before arriving there. But in seawater, chloride and sodium do not hold hands. They move separately like two companions who only meet again when conditions allow. And it is when the water evaporates that these two elements finally come together, sharing that electron so sorely lacking in one and so abundant in the other, a gesture of chemical solidarity that is almost poetic. But this story does not end there, because the question we naturally ask ourselves is, where does all this salt come from? We must go back nearly 4 billion years, to a time when the Earth, still young and boiling, was nothing but a succession of active volcanoes spewing steam and gases into a still hostile atmosphere. Among these gases, sulfur and chlorine, which mixed with the newborn water, would dissolve into the first oceans, already giving a salty taste to those primitive waters. And if chloride brings the flavor, sodium makes our taste buds more sensitive to this perception, creating a unique sensation that we still know today. Sodium, like potassium, magnesium or calcium, is also found in the rocks that cover our planet. And since forever, rain through its runoff has torn these elements from the mountains and carried them to the oceans. A cycle that has never stopped. Rivers and streams all over the world pour more than 2 billion tons of minerals into the seas every year, perpetuating this invisible link between the earth and the ocean. At this point in history, we must pause. Because if this scientific and natural adventure fascinates you, then you must subscribe and activate the bell. Because what you are discovering is only a tiny part of the wonders we will explore together, and you definitely don't want to miss what's next. But let's return to this intriguing question. Why does salinity remain stable? Why does the salinity of the ocean not continue to increase when its inputs are constant? It is because the environment also absorbs these elements, naturally balancing the system. Potassium, for example, is fixed in the clay present at the bottom of the oceans. Calcium is captured by marine organisms that build their shells, and sodium itself integrates into volcanic rocks. Thus, for millions of years, the level of salt in the oceans has remained remarkably stable. Yet despite this balance, it must be remembered that this water is undrinkable for humans. It is a question of osmosis and cellular balance. Our countless and fragile cells contain water and mineral salts. When we consume a very salty food, the salt disperses around our cells, creating a higher concentration outside than inside. To restore balance, the water contained in the cells migrates outward, seeking to dilute this excess salt. But this migration deprives our cells of hydration, leaving us even thirstier than before. That is why drinking seawater does not quench thirst but worsens dehydration. Thus, the ocean is a perfect kingdom for swimming, floating or letting yourself be carried by its waves, but certainly not for quenching your thirst. And perhaps that is the true beauty of this infinite expanse. It welcomes us for play, for contemplation, for adventure, but it keeps its salty treasure for itself. So the next time you set foot in the Atlantic, the Mediterranean or elsewhere, you will know that every drop that touches your skin carries a story billions of years old. And you may think, smiling, that this taste on your lips is not just a simple natural seasoning, but the trace of a journey that began long before your birth. For the ocean, in its infinite patience, is not content to be just a landscape. It is the liquid memory of our planet, and every wave that breaks is a page of this endless book.